The screen is black, then a sound. A sharp metallic whistle, cutting through silence. Narrator, calm, deliberate, almost a whisper. Imagine an object. Something small, something fragile, something as ordinary as a sewing needle. Now imagine it falling. Not gently, not slowly, but at the ultimate speed. The fastest speed in the universe, the speed of light. What happens when something so insignificant moves with the force of creation itself? This is not science fiction. This is physics pushed to the very edge of imagination. This is what would happen if a needle struck the Earth at the speed of light. The camera opens on Earth from space. Calm, blue oceans, white clouds, a fragile planet floating in the darkness. Narrator. First, the numbers. A sewing needle weighs just a few grams. Something you can balance on your fingertip. Insignificant, disposable. But speed changes everything. At everyday scales, kinetic energy is mass multiplied by velocity squared. Twice the speed means 4 times the energy. 10 times the speed means 100 times the energy. But light is not just fast. It is the universal speed limit, 299,792 kilometers per second. No matter how small the object, when pushed to this limit, the energy it carries defies comprehension. Cut to a sweeping shot of an atomic explosion. Then, distant galaxies, stars igniting. Narrator. At the speed of light, the needle's energy would no longer be measured in joules, or even in bombs. It would be measured in annihilation. The needle's mass, tiny though it is, would contain energy equivalent to billions of nuclear warheads. The calculation is almost terrifyingly simple. E, mc2. Mass and energy are 2 faces of the same coin. A single gram, converted entirely to energy, unleashes as much power as Hiroshima, multiplied by 20. Now imagine several grams, and imagine them delivered not as radiation from within, but as an unstoppable blade tearing into the Earth. The screen fades to black. Narrator. But here we must pause, because reality itself puts up a barrier. According to Einstein's theory of relativity, no object with mass can ever reach the speed of light. It would require infinite energy, infinite acceleration, a breaking of the rules of the cosmos. And yet, this is a thought experiment, a question of what if. So let us suspend reality for just a moment. Let us allow a single needle to break the laws of nature and see what follows. Cut to Earth's atmosphere. A streak of light appears sharper than a meteor. Narrator. The instant the needle touches air, there is no resistance. No slowing. At light speed, collisions occur faster than atoms can react. Molecules do not bend, they shatter. The atmosphere itself becomes plasma, torn apart in a flash brighter than the sun. Within less than a fraction of a second, the sky above Earth ignites. The shockwave rips outward at hypersonic speed, flattening everything in its path. Entire continents feel the blast before human eyes can even process what is happening. But this is only the beginning, because the needle does not stop. It slices through the crust as though it were paper, through rock, ocean, mountain, straight into the mantle, still moving at light speed. Visual, a glowing line burrowing through the planet. Narrator. At these energies, matter itself ceases to behave like matter. Atoms are compressed, shattered, melted. The kinetic force converts instantly into heat, radiation, and seismic shock. For a brief moment, the path of the needle becomes a tunnel of fire. The shockwave travels outward. Earthquakes of impossible scale rip across the surface. Entire tectonic plates fracture. Volcanoes erupt simultaneously. Oceans rise into tsunamis miles high. The ground itself is no longer stable. It becomes liquid rock, and then just as suddenly the needle exits the other side of the planet, still moving at light speed. But Earth is not the same. Cut to a slow pan of a dying world. Narrator. The energy released would be greater than the impact of the asteroid that killed the dinosaurs. Greater than every nuclear weapon ever built, detonated at once. In truth, it would rival the force of celestial collisions. When planets crash into planets, when stars collapse, when galaxies tear at each other with gravity, the Earth could not withstand it. The needle would not merely pierce the planet. It would destabilize it. Fractures would split the crust apart. Mantle material would surge outward. The delicate balance of orbit, spin, and structure would fail. Within hours, perhaps minutes, Earth would be unrecognizable. A world torn open from the inside. Cut to historical context. Craters on the moon. Meteor strikes. Narrator. History offers us glimpses of this power. 65 million years ago, a rock just 10 kilometers wide ended the reign of the dinosaurs. Its energy reshaped the planet's climate, its ecosystems, its future. But the Chicxulub impact was slow compared to light. That asteroid traveled at 20 kilometers per second. Fast, yes, but still just a whisper compared to 300,000 kilometers per second. Even the most violent natural impacts we know of, asteroids, comets, supervolcanoes, are tiny sparks beside the fire of a single needle at light speed. In human history, no weapon, no technology, no imagination has approached this. It is power far beyond us. Power usually reserved for the universe itself. Cut to galaxies colliding, black holes devouring stars. Narrator. When we ask, what if, we are really asking about limits. The limit of energy. The limit of destruction. The limit of our ability to comprehend forces greater than ourselves. In this scenario, the limit is clear. The Earth does not survive, not because the needle is large, not because it is heavy, but because speed transforms the ordinary into the unimaginable. Visual. Earth breaking apart, pieces drifting into space. Narrator. As the planet shatters, fragments of Earth scatter into orbit. Some pieces fall into the sun, others drift outward, forming a new asteroid belt. The blue world we knew is gone, erased by a single object smaller than your finger. Life ends. Civilization ends. The story of humanity ends, all because of one impossible collision. The camera pulls back. Earth is gone. The stars remain. Silent. Narrator. So what does this mean? Why does such a thought experiment matter? Because it reminds us of scale. That the universe operates on energies we can barely calculate. That what we call catastrophic, what we call apocalyptic, is still small, compared to what is possible. A sewing needle. The simplest object. At the speed of light, it becomes a weapon of gods. The screen fades, leaving only darkness. Narrator. Quiet. Reflective. But here is the question that lingers. If the tiniest fragment of matter can erase a planet, then what other possibilities lie hidden in the laws of physics? What if speed, energy, and matter could be pushed further, twisted further? What if, one day, we found a way? The silence grows. A faint hum builds, the screen goes black.